Hello, hello. Hello everyone, good evening. So I think I'm audible, right? Can anyone let me know whether I'm audible or not? Yes, thank you. So we'll start our first session. So first of all, apologies for long delay, right? So due to you can see my backgrounds are changed. So I was busy in shifting homes and many things. So we will start from now on. We will be consistent, and then we will proceed like before, right? We'll be very consistent from now on. Voice is very clear, right? Yes, okay. So we'll start real analysis, which is paper two, which comes under paper two, right? So I can expect minimum 40 to 50 marks from real analysis, which is very easy. So it will be when you see previous year's questions point of view, most of the questions will be like a problem point of view only. So even though it is theory based, but you look at previous year's questions and many 5 years, 6 years trends, nowadays they are focusing more on problem point of view than theory point of view, right? Okay, so we will start our first session on real analysis, right? We will start our first session. Yes, so first what I will do is I'll just break the syllabus. So you can see we're going to cover 5 topics, right? So we're going to cover 5 topics. First topic is sequences. So if I cover these 5 topics, then syllabus will be right. So as easy as that. So what we will do is I will give you the best course on real analysis. So we will cover these 5 topics and then we will solve last 5 to 8 years previous year's question. Right. So we will solve all this. I'll assure you this is one of the best real analysis course you can get in the internet. Okay. So first we'll be starting with sequences and then series and its convergence. That is important topic, and then Riemann integration, very important, and then a sequence and series of functions. So for sequence and series of functions, we'll be discussing about continuity, uniform continuity, differentiability, integrability for a sequence of functions, and then improper integral. See, some topics will be common in differential calculus and analysis. So, for example, limits, continuity, differentiability, these are the things that we already covered in calculus. So, I will not cover again that topic here. So, real analysis only these 5 topics, right? So, when you see limits, continuity, differentiability, just transfer that to calculus because already in calculus we have covered that. Okay, good. So, we'll start fresh. So, we'll start paper two. In paper two, first topic is real analysis. So we will go one by one. I'll complete theory part, these 5 theory part first, and then we will solve PYQs, and then we move on next chapter. Good. So in this class, I'll be starting sequences. I'll be starting sequences. So first, what we'll do is we will define what is sequences. It will be a little bit boring this class because these are very basics. Sequences and what is convergent sequence, what is divergent sequence, what is bounded sequence, what is oscillatory sequence, what is Cauchy sequence, and then we will do some problems on sequences, and then we will prove that some theorem on Cauchy sequences. This is what we're going to do today. So we're going to start sequences. Uh, we will start. So first, what we'll do is everything fine, right? Is there any doubts you need to ask? Before that, we'll move on to. Before that, is there any doubts? My voice is very clear, right? Or is there any lag? Or is there any disturbance? Or is there any fan noise? Or is there any some noise coming around? If yes, I can work on it because I don't know. After a video, if it is not good, means it will not be good. Anyone, just make sure that my voice is steady without any disturbance, right? Okay, good. So what we'll do is we will start our first topic, which is sequences. So we're going to study about only real numbers. So sequences of real numbers, series of real numbers, everything is on real numbers, right? Because it is real analysis. Okay. So first what we'll do is we will define what is sequences. If I say sequences, it is real sequences, right? It is real sequences. That is output is real number. That's it. So first what we'll do is we will define what is sequences. Definition point of view, I'll just write it very fast so that we will move on to problem quick. Okay, so first what we'll do is we will define what is sequence. Sequences. Okay, the sequence. A sequence is a function, right? A sequence is a function whose domain is the set of natural numbers. Domain is the set of natural numbers, and a range may be, and the range is a any subset of real number, right? And a range is a subset of real number, or it can be a real number also, right? So that means a sequence is a function from natural number to real number, right? If range is a subset of real numbers, we say it is a real sequence because we are talking only real numbers, right? So real sequence. So your input has to be natural number because your domain is natural number, and all your outputs has to be in the real number. That's it, right. If your outputs are in real number, then we say it is a real sequence. So sequence is a function from natural number to real number. For example, these are very basic. So let us take an. Let us take an to be 1 by n. So this is sequences, right? So when here I need to start with n is equal to 1 because you can see my domain is natural number. So I can put n is equal to 1. That is my starting number, right? So for example, what is my a1? A1 is 1. For example, a2. So a2 will be 1 by 2, and a3 will be 1 by 3, and so on, right? Now, you can define many sequences like this, right? So first is an is 1 by n, and let us take an to be n square. In that case, your a1 will be 1, your a2 will be 4, and then your a3 will be 9, and so on. So your input has to be natural number. Output can be anything that is a subset of real number. So we say it is a real sequences, right? We say it is a real sequences. Okay, then what is range of a sequence? So you can see when I give the inputs of natural number, you can see all the outputs are, but you collect all the outputs. This is what we do in 10th standard, 11th standard, 12th standard, right? Range. You know how to find range. That's everything about range. So you collect all the outputs and put it in one set. That set is called the range, we will say, right? So same is called range. So first, what we'll do is we will define a what is meant by bounded sequence, right? So first definition is what is a real sequence. So what is sequence? So sequence is the function from natural number to a subset of real number. That's it. So your domain has to be natural number. Range can be any subset of real number. You have to start by plugging n is equal to 1 because your domain is natural number. Yes. Okay. So first, now we will define what is meant by bounded sequence. Very important. We will define what is meant by bounded sequence. So to define what is meant by bounded sequence, first we need to know what is meant by bounded above sequence, and then we need to know what is meant by bounded below sequence. So first what we will do is we will define what is meant by bounded above sequence, right? So we will define what is meant by bounded above sequence. So a sequence an is said to be bounded above, is said to be bounded above, right? We say a sequence said to be bounded above if there exists a real number k, if there exists a real number k such that an is always less than or equal to k for all n belongs to natural number. You can see if all the terms of the sequence are less than some number k, then we say it is bounded above sequence. Yes or no? If all the terms of the sequence, this means there exist. These are all you know, right? If we say bounded above sequence. What is bounded above sequence is see nothing. What is bounded above? If the range set is bounded above, that's it. See what is range set? You give inputs as natural number. You will be getting all the outputs as a subset of real number. If all the outputs are less than some number k, then we say that sequence is bounded above. That's it. A sequence an is said to be bounded above if there exists a real number k such that all ans are output, right? Because a1 for all n belongs to natural number, all the terms of the sequence are less than some number k. That means we say this is a bounded above sequence. Then what is bounded below? You can define in your own, right? Bounded, I'll give you example, right? Don't worry. Bounded below sequence. So what is bounded below sequence? A sequence an is said to be bounded below a sequence. Get comfortable. Okay. A sequence an is said to be bounded below if there exists a real number k, right? Already we have used k, so don't get worried about this k and this k, right? Our example, let us say this is k1, let's say this is k1, right? There exists a real number k2 such that all the terms of the sequence are greater than or equal to k2 for all n belongs to natural number. That is, all the terms of the sequence are greater than this number. That means it is bounded below. So here you can see all the terms of the sequence are less than some number k. But here you can see all the terms of sequence are greater than that number. Then we say it is a bounded below sequence, right? Just a normal English. We have something. It is bounded above. It is bounded below. That's it. Bounded above means there has to be some upper limit. Bounded below means there has to be some lower limit, right? So you know what is meant by bounded above. You know what is meant by bounded below. If you see if a sequence is bounded above as well as bounded below, then we say that sequence is a bounded sequence, right? What is bounded sequence? A sequence is said to be bounded if it is bounded above as well as bounded below. A sequence an is said to be bounded. If I say bounded, it has to be bounded above as well as bounded below. A sequence an is said to be bounded if it is bounded above, as well as bounded below, right? If it is bounded above as well as bounded below, if it is both bounded above as well as bounded below, then we say that sequence is a bounded sequence, right? I'll give you some examples. I'll give you some examples. Let us take some examples, right? Let us consider the sequence. Let us consider the sequence an 1 by n, right? Now, what is the range of the sequence? If I put an is equal to, if I put n to be equal to 1, we will have 1. If I put n to be equal to 2, we will have 1 by 2, and then 1 by 3, and 1 by 4, and 1 by 5, and so on, right? You can see all the terms of the sequence are less than 1. Yes or no? You can see all the terms of the sequence are less than 1. Yes or no? All the terms of sequence are less than 1. That means the sequence is bounded above by 1. The sequence is bounded above by 1. As well as you can see all the terms of the sequence are greater than 0. Strictly greater than 0 because I cannot put greater than or equal to 0, right? Because when n tend to infinity only, this will tend to 0 because 1 by infinity will tend to 0. You can see 1 by 5, 1 by 4, 0.25, 1 by 5, 0.20, 1 by 6, 1 by 7, 1 by 10, 0.1. So you can see it is approaching 0, but it will never be equal to 0. That means all the terms of the sequence are greater than 0, and all the terms of the sequence are less than 1, right? So that means you can see this an is bounded by 0 and 1, right? It is bounded above by 1, it is bounded below by 0. So that means this sequence is it is a bounded sequence, right? It is a bounded sequence. What are the bounds? It is a bounded sequence. That means it is bounded above by 1 and it is bounded below by 0. Bounded below by 0. That means this sequence is a bounded sequence, right? It is bounded above as well as bounded below. Now I will give you one more example. Let us take an to be equal to minus 1 whole power n. Minus 1 whole power n. What are the outputs for this sequence? It will be 1 or minus 1, right? If I put n to be equal to 1, it will be minus 1. If I put n to be equal to 2, it will be plus 1. If I put n to be equal to 3, I'll get minus 1, plus 1, minus 1, plus 1, minus 1, and so on. Now we can see our an is always greater than, that is, it lies between minus 1 and 1, right? That is, our sequence always lies between minus 1 and 1. So it is bounded above by 1 and bounded below by minus 1. So that means this sequence is also a bounded sequence. Sequence is also a bounded sequence, right? The sequence is also a bounded sequence. Is it clear up to now? Is it clear up to now? So let us take a to be equal to n. What are the terms of the sequence? That is, what is the range? You'll get 1, 2, 3, 4, 5, 6, and so on. You can see our sequence is bounded below by 1 because all the terms of the sequence are greater than 1. But it is not bounded above, right? You can see whatever they said. 1 lakh is the maximum number, sir. I can say that is 1 lakh 1. That number is greater than 1 lakh. That means it is not bounded above, right? So that means the sequences, all the terms of the sequence are greater than or equal to 1. That means it is bounded. It means it is bounded below, but it is not bounded above. So that means the sequence bounded below, is bounded below, but not above. Right? That means the sequence is not a bounded sequence. If it is bounded above as well as bounded below, then we say that sequence is a bounded sequence, right? For example, let us take an to be equal to minus n, right? Here, what are the terms of the sequence? Minus 1, minus 2, minus 3, minus 4, minus 5, and so on. Now, this sequence is bounded above by minus 1, right? Because all the terms of the sequence are less than or equal to minus 1, but not the sequence is bounded above. Sequence is bounded above. The sequence is bounded above, but not bounded below as well as bounded above, right? Sorry, the sequence is bounded above but not bounded below, right? Yes. So the sequence is bounded above. The sequence is bounded above, but not bounded below, but not bounded below, right? Let us take a sequence. Let us take a sequence an to be equal to minus 1 whole power n into n, right? What about this sequence? What about the term of the sequence? If I put n to be equal to 1, what you will have? It will be minus 1. If I put n to be equal to 2, what do you will have? If I put n to be equal to 2, what do you will have? If I put n to be equal to 2, it will be plus 2. If I put n to be equal to 3, it will be minus 3. If I put n to be equal to 4, it will be plus 4. Now we can see the sequence is not bounded above as well as bounded below, right? Because there is no number k, you can say that an is less than k for all k, right? So this is um, not not bounded above, not bounded above as well as bounded below, not not bounded above as well as bounded below, right? So I think, is there any clear up to now? Is there any doubt up to now? I think my camera is big, I think, right? Just fonts are missing. See, this is what I wrote: bounded above but not bounded below here, right? Bounded above but not bounded. Make sure that I will not write. Okay, make it here. Okay, that's good. So as of now, we have discussed what is meant by sequences, and then we have discussed what is meant by bounded sequences, right? Yes, good. Akash, I'll get back to you. You just text me in Telegram, right? Okay, good. So what we'll do is we will define what's meant by convergent sequence now. So that is the third definition we're going to see. So we're going to see six definitions, and then we'll be moving on to problems. Convergent sequence, right? Okay. So we will define what is meant by convergent sequences. See, if limit n tend to infinity, if limit n tend to infinity a n is equal to L, right? And this L is finite, right? If we have a sequence an, if limit n tend to infinity, you just find the limit at infinity. If it is equal to some finite number L, then we say then we say that the sequence an converges, it converges to that number L, right? Converges to that number L. Okay, so if limit n tend to infinity, so we have a sequence an. If limit n tend to infinity for that sequence, if it is going to a finite number L, then we say that sequence an converges to L, right? So equivalently, this is important. So equivalently, a sequence an is said to converge to a real number L, is said to converge to a real number L if given epsilon greater than 0. So you give me any epsilon that is greater than 0. So you are giving me an epsilon, right? So a sequence an is said to be converged to a real number L. See, this is equivalent definition, right? For proving point of view, we'll be using, for problem point of view, we'll be using this. A sequence an is said to converge to a real number L if given epsilon greater than 0, however small. So you give me any epsilon, however small. You can give epsilon to be 0.000001. You give epsilon to be 1 by 10 lakh. You give epsilon to be 1 by 1 crore. You can see that epsilon is very, 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 very small. A sequence an is said to be converged to a real number L if given epsilon greater than 0, however small. You give me any epsilon greater than 0. You are giving me an epsilon. There exists a positive integer m. There exists a positive integer m. Whatever epsilon you give, I can always find a positive integer m, and this m depend on your epsilon. right? With your epsilon only I can find a m. There exists a positive integer m. This m depends on epsilon, right? Depends on epsilon such that the distance between an and L will be less than epsilon for every n greater than or equal to m, right? This is the equivalent definition of convergent sequences, right? Okay, I'll give you an example. That means you are giving me an epsilon. I can always find a positive integer m. How I will find m? With the help of your epsilon only. I can always find a positive integer m. Whatever n I choose that is greater than or equal to m, then the distance between an and L. Whenever I put modulus, you should always think of a distance, right? Because distance between two numbers is nothing but modulus of difference of that number. So the distance between an and L will be less than epsilon for all n, for every n greater than or equal to m. I'll give you an example. Let us take uh, let us take let us take a sequence. Let us take a sequence an to be equal to 1 by n. Now, what is the limit of the sequence? What happens when limit n tend to infinity of an? So, it will be limit n tend to infinity of 1 by n. You can see it will be tending to 0, right? That means our L is 0. Because when n tend to infinity, this sequence is approaching 0. That means it is a convergent sequence and it is converging to what? It is 0. It is converging to 0, right? Yes. Now, now we know that the sequence is convergent, and we already know what is the limit of the sequence. What is the limit of the sequence? It is 0. Now, if I want to prove that the sequence is convergent with the help of this, the sequence an is said to be converged to a real number L given epsilon greater than 0. So you give me any epsilon greater than 0, right? For example, let us take you are giving me epsilon to be 0. Let us say you are giving epsilon to be 0.001, right? Given epsilon greater than 0. So you are given me an epsilon. However small, you give me any epsilon. There exists a positive integer m, right? There exists a positive integer m. So I need to find m, right? I need to find m. There exists a positive integer m. Depends on epsilon. So how to find that m? How to find that m? That we will do now. After finding m, you take a number that is greater than m. For example, let us take n. Then the distance between the distance between an, that is this n that you have chosen, that is greater than m, and the limit, the distance will be less than epsilon, that is less than 0.001. Now you have to find what is that m, right? So you are given me epsilon to be 0.001. Now I need to find m, right? I need to find m. We will find m now. Now we know distance between an and L is less than epsilon for every n greater than or equal to m. So we have an. What is our an? An is 1 by n, and we know L is and we know L is 0, right? We have n to be equal to 0. Yes. Now this means 1 by n is less than epsilon. That means 1 by n is less than epsilon means what about n? What about n? 1 by n is less than epsilon. And what is epsilon? What is epsilon now? We have chosen epsilon to be 0.001, right? That means 1 by n is less than, this is 1 by 1000, right? So this implies 1000 is less than n. That means n is greater than 1000, right? Yes. Now you can see there exists a positive integer m. There exists a positive integer m such that the distance between a and L is less than epsilon for all n that is greater than or equal to m. For example, let us choose I think I made some notation error here, I think. An is equal to 1 by n, limit n tend to infinity, an is 0. So we have epsilon to be 0.01. That means if your n is greater than or equal to m, then the distance between an is an minus L, an and an minus L is less than epsilon for all n that is greater than or equal to m. Okay, for example, what I can choose is what you take any n that is greater than or equal to m. What m I can take? You take any m that is greater than or equal to n. So we have n to be greater than 1000. That means you can take m to be any number that is less than or equal to n, right? So for example, if I take m to be 9999, right? If I take m to be 9999, right? Because we have n is greater than 1000, right? That means I can take m to be 999. Then I have made some notation error. N is 1 by n here. So there exists a positive integer m depending upon epsilon. Okay. So I think for finding m, let us put this as am, right? Let's put this as m. Then it will be clear, I think. Just a minute. Thanks, Okay, got it. See, here you take m to be equal to 1000, right? We have got n is greater than 1000, right? Let us take m to be greater than 1000, right? Because we have assumed epsilon to be 0.001. Now you take any n that is greater than m. Let us take n to be equal to 1001. Then the distance between a 1001 minus L will be less than epsilon. Yes or no? Because what is a 1001? Will be 1 by 1001 minus L, and this will be less than what? 0.001, right? 0.001. So what definition says is a sequence an is said to converge to a real number L if given epsilon greater than 0, right? If given epsilon greater than 0, however small, there exists a positive integer m, right? This m depends on epsilon such that distance between an minus L is less than epsilon for all n that is greater than m. So we have shown m is greater than 1000. So if I take any number that is greater than 1000, the distance between a 1000, the number greater than 1000 minus L will be less than epsilon, right? Okay. Now we will define what is meant by divergent sequences.